Hello everybody, I am Suman Matthews and today I will be discussing how to calculate the rank correlation. This is a part of grade 11 maths and also a part of college maths for students taking statistics as a subject. I have been teaching mathematics for the past 25 years and in this video we will be illustrating the method of calculating rank correlation, and we discuss problems when the ranks are repeated and not repeated. So work with me through this entire video. Correlation coefficient between two series of ranks is called the rank correlation coefficient. In a previous video, we had discussed the correlation coefficient. The formula for the coefficient of correlation was given by Spearman, hence it is called Spearman's rank correlation coefficient, and it is given by the formula R equal to 1 minus 6 summation d squared by n into n squared minus 1, where d is the difference between the ranks and n is the number of items. The marks obtained by two students in physics and maths are as follows. Calculate the ranks in English and maths are as follows. Calculate the ranks in the two subjects and the coefficient of correlation of ranks. So we have English and maths. Now the highest, going to English, the highest value is 47. We are arranging it in descending order. So next to 47 we write 1. Then we have 43, so we write 2. Then we have 35, which is 3, 28, which is 4, 23, which is 5, 17, which is 6, 10, which is 7, 9, which is 8, and 6, which is 9. Again, coming to maths, we have 49 is the first rank, then 45 is second, 33 is third, 31 is fourth, 30 is fifth, 23 is sixth, 12 is seventh, 8 is eighth rank, and the ninth rank is 4. We take the difference between the two ranks as d equal to r1 minus r2. So 3 minus 5 is minus 2, 5 minus 3, 2, 1 minus 2 minus 1, 6 minus 6, 0, and so on. We calculate d squared, 4, 4, 1, 0, and so on, and the sum of d squared is 12. So r equal to 1 minus 6 summation d squared by n into n squared minus 1, that is 1 minus 6 into 12 by 9 into 81 minus 1, which is 0.9. So there is a high degree of rank correlation. Question 2. The coefficient of rank correlation of marks obtained by 10 students in physics and chemistry was found to be 0.5. It was later discovered that the difference in ranks in two subjects obtained by one of the students was wrongly taken as 4 instead of 8. Find the correct coefficient of rank correlation. Now R is given to be 0.5. So by our formula, 0.5 is 1 minus 6 summation d squared by n into n squared minus 1. So we substitute the value of n as 10 and we get summation d squared is 122.5. Now one rank was wrongly taken as 4. So we subtract 16 from summation d squared instead of 8 and we add 64. So the correct summation d squared is 170.5. So r equal to 1 minus 6, the correct summation d squared by n into n squared minus 1, that is 10 into 99. So we get the answer as minus 0.033. This is a low degree of rank correlation. The following table gives two kinds of assessments. Find Spearman's coefficient of rank correlation and interpret the results. So we have assessment 1 and assessment 2. Now here the ranks are repeated. Now if you look at it, there are two first ranks, 50 and 50. Average of 1 and 2 is 1.5 because 1 plus 2 is 3. 3 divided by 2 is 1.5, so we write 1.5 next to 50. Now the second rank is not there, so 40 will be the third rank. Then we have there's 1, 2, 3, 3 30s. So 4, 5th, 6th, the average of that is 5. So next to 30 I write 5. Then we start with the next value would be 20. There are two 20s, so average of 7 and 8 will be 7.5. So next to 20 I write 7.5. So the 8th rank is gone. The 9th rank is 10. 10 is the 9th rank and 0 is the 10th rank. Again, coming to assessment 2, the first rank is 50. Then the second rank will be 45. And we have 2 40s. So average of third and fourth will be 3 plus 4, 7 by 2, 3.5. So next to 40 we write 3.5. Now the fourth rank is gone. 30 will be the fifth rank. Again we have 2 20s. That is the 6th and 7th. 6 plus 7 by 2 is 13, which is 6.5. So next to 20 we write 6.5. The 6th and 7th rank is gone. Then we have 2 15s. So 8th and 9th. 8 plus 9 is 17. 17 by 2 is 8.5. So next to 15 I write 8.5 and 10 is the 10th rank. We then take the difference D as in the previous problem. 5 minus 8.5 is minus 3.5. 7.5 minus 3.5 is 4. 3 minus 3.5 is minus 0.5. 1.5 minus 2 is minus 0.5 and so on. Again D squared 12.25, 16, 0.25, 0.25. The sum is 56. Now this is a formula. When a rank is repeated, R equal to 1 minus 6 summation D squared plus 1 by 12 into M cubed minus M by N into N squared minus 1, where M is the number of times a rank is repeated. Now 50 is repeated 2 times, 30 thrice, 20 twice, 40 twice, again 20 twice and 15 twice. So we can see that 5 values are repeated twice and 1 value is repeated thrice. We need to keep track of this, otherwise it gets confusing. So R equal to 1 minus 6 into 56 plus 1 by 12, 2 cube minus 2 because 5 values are repeated twice and 1 value is repeated thrice by N into N squared minus 1. So you get the answer as 0.633. So this is a moderate degree of positive rank correlation. For more videos, subscribe to my channel.